Hello students, how are you all? So today we are going to start the mensuration part. According to your reduced syllabus, we have only three things over here, that is triangle, circle and the 3D objects. So first of all, let's start with triangles. So all you need to learn the area and perimeter. We already discussed about it in our last class, but still we have to show that what is perimeter first. I told you from class 7 that is perimeter is nothing but the addition of each side. So if these three sides are given to you, then just add them together and you will get the perimeter. So perimeter is what? If any kind of shape is given to you, just add the side of that, each side of that together. So you will get the perimeter. That is the very easy part behind the perimeter. Okay, now coming to area. For area, you need to follow few formulas for this each of these triangles. As you can see, I gave all those triangles and with the following areas in this part. First of all, it is coming with right angle triangle. And we all know that right angle triangle is the half part of a rectangle or a square. So let me draw one square first. Thus you will learn it very easily by that. So let me draw a square. As you can see, you have a square right now. So I'm going to cut that square by a diagonal. So while we have that diagonal, if you notice one thing, that we actually got two parts. The upper one is number 1 and this is number 2. And each of them are right angle triangle. Acha, if I give you this is the height h and this is the base b, which is pretty obvious that those should be same because we already took a square over here. That is why all sides are equal. But in this case, we are just marking them as height and base. Just if you notice one thing, if this triangle is here, this should be your height and this should be your base. According to that, I'm taking all these data. Okay. So certainly, what should be the area of the square? So the area of the square will be h into b. That's what we know. But when you draw the diagonal, that diagonal is cutting the whole circle into two equal parts. So each part should have half of the area. That is why the formula is half height into base. That formula is basically come from the rectangle because we know that there is only length and breadth. Two sides are opposite sides are equal, not the perpendicular sides. So you can do the same formula for the rectangle. While you will do with diagonal, you will get the same result. So what should be the main area formula? That is half height into base for a right angle triangle. Remember that. Okay, so that's enough. But always it's not mean that the right angle triangle will be given to you. They can also give some any arbitrary triangle to you, but how you can find the area of this kind of triangles? All right, for this kind of triangles, two things will be given to you. Either they will provide you the height, that is from the vertex point a perpendicular line to the base, and the whole base b. From here, we can actually find the area of this by our previous knowledge. We know that this line is perpendicular to the base. That means now we got two right angle triangles. So for each of those right angle triangle, if we try to find the area, that is our each of the parts area. Let me do it for you first. Okay, let me change the color, white. So first of all, I'm doing for number 1. Achha. I'm taking this one as B1 from here to here. So what should be the area of first? A1 equal to half of H into B1 according to the last formula. Similarly, if I take this one as B2, then this area should be A2 equal to half of H into B2. Simple as that. But what is the area of total thing. Right now, all we have to do, we have to add those together. A1 plus A2. And finally, if you put all these values together, we will get half H common with B1 plus B2. Now, if you notice one thing, this B1 plus B2 is actually nothing but the whole B or total base. So instead of B1 plus B2, we can write total base B. Similarly, you can see that the total base with multiplication of half of the height is your total area. So that is the one way to find the whole idea. If the height is not given to you, then what you will do? Let me show you another approach with that. So another arbitrary triangle is given where now each of the sides is given to you, that is A, B and C. Then how you can find the area of this? For this you need the Heron's formula. Maybe in the PDF somewhere it is given as hero formula, but don't mind, it is Heron's formula, Heron. So be careful with that. Acha. In the Heron's formula, what you have to do? The first step to find the perimeter. I told you how to find the perimeter, just add the all sides as I am doing over here. Second step, find the semi-perimeter, that is I am denoting as S. So semi-perimeter is what? The half of the perimeter. So all we have to do, we have to divide this addition with 2. That's it. Achha. So we got the semi-perimeter, that is step 1. I am marking as step 1. Now step 2 is this formula that you have to remember. So area equal to under root of S, where S is the semi perimeter as I told you earlier. Then within bracket S minus A, that means semi perimeter minus the first side, then semi perimeter minus the second side, then semi perimeter minus the third side. That is the whole formula that you have to remember. So while you will put all these values, you will get a certain area in a square unit. So that's it. It's known as Heron's formula. Okay. Now there are two more triangles that we have to learn, that is the isosceles triangle and this equilateral triangle. So for equilateral triangle we have some advantage. Why? Because we know that each of the sides of these equilateral triangles are equal to each other, right? So that is the big advantage. And this is where the vertex point is always stay in the mid of this base. So if I draw another line from the vertex point to the base, it will bisect the baseline. So if I provided that if B is the total base, then each of these parts should be B by 2. Remember that. That is very useful one. We're going to need that. So this is the base where for the equilateral one, we are actually bisecting the base by this vertex line. Remember that. And this will be also be because I told you that is equilateral triangle where each sides are same. So if I want to find the area, that is very simple, half height into base. But wait, for this kind of cases, the height will be not provided to you. You have to find it by yourself. But how you can do that? Simply by the Pythagoras theorem. If you notice one thing, there are also two right angle triangles. So if you can take any one of this. I'm just choosing this one where this is 90 degree. So right now height square plus, see, base is b by 2. So b by 2 whole square, that is base square, that is equal to the hypotenuse square, which is the b square. So by solving this one, you will get the value of the height. Which one you can put this in the area formula? Finally, you will get the whole area. That's it. This is the idea behind it. Also, same thing is applicable for isosceles triangle. I put it over here in the note. You can check it out. Same thing is occurring over there. We know that. But one more thing, that the isosceles triangle only have two equal opposite sides, this and this. And the basis should be supplied to you separately. I choose few important questions that will try to build the idea behind it. Okay. So question 3, as you can see over here, find the area of the triangle whose sides are this. So that is pretty much simple. So we have to build any arbitrary triangle according to this measurement given. Don't need to be perfect, just draw a rough diagram where you should mark all this as this is may 20 centimeter, this one may 42, and this one is 34 as I am taking. So how to find the area? All you need to know, you need to apply the Heron's formula. As I told you, whenever in this kind of cases, the sides are only given. So as you can see, first of all, first step I told you, find the perimeter. So perimeter is what? That is A plus B plus C. So 34, then 20, then 42. Finally, you will get 96. And after that, you should find the semi-perimeter, that is P by 2. So instead of P by 2, you can write S, and that is nothing but 48 centimeters. So as you can see, I already did it over here. So you have to apply all those values according to this in the Heron's formula. And finally, after solving this one, you will get a proper way to find the area. That is 336 centimeters square in this case. So that's it. Now, one more thing is there. Hence, find the length of the altitude from the corresponding of the shortest side. As you already noticed over here that 20 centimeter is the shortest side, and according to that I have to find the altitude. So that means I need to draw one line which coming from the vertex point and will end in this base perpendicularly. So I'm marking that with height h. Now I told you for arbitrary triangles we can also apply half h into b. In our note, in our previous class I told you that. So instead of this you can actually put half h into b. Now we know the area, right? And that area is 336. Okay. And this base is also known to us, that is 20. So that is 20 2h equal to 336. Finally, if you solve this one, you will get h equal to 336 by 10, and that is 33.6 centimeter. So finally you also got the height. So that's it for the number 3. I hope you got the idea. Still you have any doubt, don't forget to write in the comment section. Moving to the number 9. So this kind of ratio sum will come more in your exam. So be focused in that. If the length of the side of triangle are in ratio 3 is to 4 is to 5 and the perimeter is given, that is 48, find the area. Let me draw the triangle first. As you can see, all the measurements are not equal, so this is the arbitrary one. So 3, 4, and this one is 5. Now, whenever we deal with the ratio, we know that let the common ratio be x, and that is why each of the sides now become 3x, 5x, and 4x. That is the advantage of this one. So we know that if we add all the sides together, we will get the perimeter. And in this condition, the perimeter 48 is given to you. So all you have to do, you have to add them together. By adding them together, you will get 12x. And finally, as you can predict, it will be 4. So the common ratio be 4, then each side should be 3 into 4, 12. Then B 4 into 4 16, and C 5 into 4, that is 20, all in centimeter. Don't forget to give the unit, those are most important. Right now you got all the values. That is, this one is, you can also erase this one. Wait a minute, just erase them. And right now we have to put the real values. That is 12, 16, 20 and 16. So all you need to know that about Heron's formula. So when you apply the Heron's formula, that's it. You will get the answer. I did it over here. Please check it out. And if you have any query about it, you can write it in the comment section. Okay, so that's it about the ratio part. Now coming to number 11. Find the area of the isosceles triangle whose equal sides are 12 centimeter and the perimeter is 30 centimeter. So equal sides are given, right? So that is 12 plus 12. I'm taking the base as b, that is unknown to us, and the perimeter is given, and the perimeter is 30. So as you can see, you will get the base value very easily from here. That is 24 minus, which will give you 6. So the base is 6 centimeter. All you have to find the area. So right now you got A value, that is 12, B value also is 12, and C value you just find it out as 6. Okay, I'm taking here as B, that one. So you should change this. Wait a minute. So this is C, this is A, and this is B. That is how I'm taking over here. So we already know that this are 12 and we just found that C is 6. So that is how we got all the sides, and now it's time for Heron's formula to apply it. Okay, moving to the next sum. The base of the triangular field is 3 times its height if the cost of cultivating the field at the rate of 25 rupees per 100 meter square is 60,000 total. Then find the base and the height. Step by step we will complete this one. Wait a minute. First of all, triangular field is given. We don't know what kind of triangle is that, so we are assuming that is certain arbitrary one. So triangular field is of 3 times its height, its base. So that is the trick over here, that the relation between height and base. So I'm taking the height, this height as h. Let the height is h. You have to write it like that. Then what should be your base as it is given? 3 times of height, 3h. So that's it. The first thing that you need to know. Okay. So the pricing is now given to you in the second condition. That means 25 rupees per 100 meter square. Then the total costing is right now 60,000 rupees. So you invested 60,000 rupees and you know that it cost for 100 meter only 25 rupees. So all you have to do, you need to find that how much money, sorry, how much area is there. So 60,000 for, wait a minute, let me do it with unitary method. Alright. So first of all, 25 for 100 meter square, then 1 for 100 by 25 meter square, then 60,000. I think now it is clear to all of you. 100 by 25, that should be 4, and 60,000 will be multiplied with that. So finally you will get 2,40,000. Yes, and that is in meter square because this is your area right now. So you know the area, and one more thing you have to find the base and height. So you know the area, and the formula is what? That is half into h into b. That should be equal to the area. So also one more thing you have to do over here, instead of b you should write 3h. So finally you will get 3h square is equal to a. So as you can see, h square is equal to 2/3 of 240000, and that is very much easy to find. That it will be cut as 8 then you will get the 16 and another 4 zeros along. So it is h square. Then what should be the value of h? That is 400 meter should be the height. So that's it for the height. Now we know that 3h is the base, so just multiply that with 3 into 400, it will be 1200 meters. So you got the base and the height as required over there. I hope the idea is clear. Still, if you have any doubt regarding this one, you can write it anytime. Okay, so coming to number 21. That 21 is pretty much special for you because as you can see, the diagram is a little bit tricky to you. First of all, I will actually explain you how to think about it, how to actually complete that, what you should do first, which one you should take next. As you can see, there are two triangles and they are not even touching. And it is told that find the shaded region. This part is totally shaded. You have to find this region's area. Few more measurement is given, that is this one is 6 centimeter, the base is 10 centimeter, and this bigger triangle is explained as equilateral one. So that is all we got over here. Finally, what you have to do, you need to find the area of the shaded region. First of all, as you can see, this smaller one, let me name it with T. So the right angle triangle BDC, right angle triangle BDC, we can find the height. And by that we can actually complete the area of that. So first of all, you have to find this part, that is I'm marking as A. How we will do that? If you notice one thing, this is your height, this is 10 is your hypotenuse and 6 is your base. So we know that a square, that is height squared, with base squared, that is 6 square, should be equal to hypotenuse square. So a square is equal to 100 minus 36, and that will come as a square, that is equal to, you will get over there 64, and a equal to 8. So that's it. We got the value of this part, that is 8 centimeter. Now by applying Heron's formula, you will get the area of this. Acha. So we got area of this, A2. Now we have to find the area of bigger one. How we can do that? It is told that this bigger one is an equilateral triangle. So as you can see that this is 10 of each side. So each side will be 10 centimeter, right? So by also Heron's formula, you can have the area of the bigger one. So that's it. Just subtract the smaller one from the bigger one and you will get the required area. So this is the topic behind it. I already did that in this whole thing. Let me show you once. As you can see, all the sums as I explained is totally given over here. You can check it out. If you still have any doubt, don't forget to write it in the comment section. We are back with the mensuration part. Next part is circle right now. So in this circular part, all you have to think is about the area and the circumference of the circle. Remember I told you in our last part that is the perimeter of circle. This time it's all about the perimeter is known as circumference. If you notice one thing, how you can measure the circumference? There is, for that there should be some particular formula, right? And that formula is 2 pi r, where the r is the radius. So the r is the radius and the perimeter is 2 pi r. Now about area. What should be the area of circle? That is pi r square. So as you can see, the perimeter and the area, this all are depending upon the radius of the circle. So the most important thing for the sums of circle is the radius. All you have to do for each kind of sums of the mensuration for circle, you have to find the radius first. While you will got the radius, whatever you want, you can find from that. So one more thing I should mention over here, according to your reduced syllabus, only the quarter and the semicircle is in your syllabus. Rest of the 3/4 part and more than others is not included in your syllabus. So remember that. So let's start with few ideas behind it. I just told you about the area and the perimeter of the circle. Right now, I will take two same kind of circle, and mostly I should say two concentric circle. As you can see, this is one circle and inside of that we have another circle. Yeah, finally you got pretty much a concentric circle. That's better to explain. So we have two circles right now with same center, that is 0 or O. So this is say R1, and the bigger one I'm taking as R2. As you can see, I'm marking from here to here, that is R2. So what you have to find over here? You need to find the area inside, or you can say between these two circles. Alright, this is the shaded region. You have to find the area of that. I think you already know that how to find this one, that you need to subtract the area of the smaller one with the area of the bigger one. That is the only way to find this one. So this is your master formula. Right now we know that is pi r squared is the formula, right? So instead of a1 and a2 we can write pi r2 square and pi r1 square. Just notice one thing, that you can take out the pi as common, and this is right now your master formula where you are getting this as your area of the shaded region. So this is how you have to find the area for a circular ring. Similarly, let me show you two more about this. First of all, semicircle. If a total circle is given to you, what is semicircle? That is nothing but the half of that, right? So what should be the area? We know the circle have area pi r square, where r is the radius. Then for semicircle, what should be the area? The half of the area, that is a by 2 or pi r square by 2. That is this part only. Simple. Acha. What should be the quarter part? Let me mark it over here also. This is the quarter part, that is 1/4 part. Then what should be the area of the quarter? Let me write it as semi and this one as quarter. So as it is already a by 2, it's got halved. For the quarter it is got divided by 4, a by 4. So 1 by 4 pi r square. All you have to remember the first formula, that is the area of the total, and sequentially you will get that the area of the half, that is for semicircle, and the area of the quarter part, that is for a by 4. So that's it about the measurements and formulas behind it. Now let's jump to the exercise. So number 4, find the radius and the circumference of the circle whose area is given as 144. So right now the area is given. What I told you first, by the given condition, always you have to find the radius first. So in this case, you need to find the radius. Okay, we know that the area is pi r square, so we can put it like that. Alright, so pi and pi going to cancel together. If just will remain, that is r square equal to 144, and in fact I can also take the unit in whole square. Wait, that should be then 12. Let me change it. So as you can see, I am also taking the unit also, that is previously in centimeter square, I am taking as whole. Right now r should be the radius, that having the unit centimeter only. So both sides the square are getting root. Finally you are getting 12 centimeter as your answer. So that thing is your radius. All you have to find right now, you have to find the circumference. We know that that is 2 pi r for the circumference. So just multiply with 2 pi with the 12. Finally, we'll get 24 pi centimeter. That's it for the answer. So very simple one. For number 4, still if you have any doubt, write it in the comment section. I will surely help you. Coming to number 11, as I told you about the circular ring concept, one kind of sum is given over here. I will do one part A. I'm giving you as homework one part B. You should submit it. Okay. So in 11 part A, part 1, the area enclosed between the concentric circles is 770. Right now, this area, shaded area is given to you. Okay. Given that the radius of the outer circle is 21 and calculate the radius of the inner one. Okay. So we got the idea first. We have two concentric circles. The inner radius is given to me, that is, sorry, the inner area is given to me, that is A equal to 770, and the outer one's radius, that is 21, is given to me. All we have to find the area of the inner one. How we can do that? Let me show you. So I told you already about the first formula, right? That is the master formula, pi r2 square minus r1 square for this kind of cases. And for this actually I built that. If you remember those formulas, that will be very much helpful for you. You can instantly put according to the given sums. So pi value, okay, I forget to tell that pi value is, there are two pi values, 3.14, and that is actually a totally continuous value. So many values are there after this, but still approximately we take 3.14. And also you can take that is as fraction 22 by 7. So in here I am taking 22 by 7. Okay. Now the outer radius, that is to R2, we have to find the inner one. So outer radius is 21 whole square minus R1 square. Okay. So this is the idea about it, and the area is 770. That is also good. So by solving it, as you can see, I will get the radius, that is 14. I already did it over here. Please check out the calculation. I just told you the part or the idea how you have to do and why you have to do this kind of things. So that is the radius of the inner circle. So as the radius is given to you, from there you can find any kind of circumference or area of inside one. That is totally up to you. Coming to 19 part B, that is the most important one. In this part, as you can see, there are 4 circles inside of this. There is one trick behind it, that is, this is a perfect square. So if I give you the each side is x, then just think from here to here it is completely x. Then if I half it, then this should be x by 2 and this should be also x by 2. Now see that x by 2 is the diameter of each circle. Then what should be the radius? Radius is also half of that, that is x by 4. So you got the radius of each circle, that is x by 4. Now let me see how much is the value given. The square value or the square sides value is given as 14. So instead of x, I can put the 14 over here. Let me cut it by 2, that is 7, so it will be 3.5. 3.5, yes, in centimeter. Now we got the radius. All you have to find the area of the shaded part. How you can do that? First of all, find the area of the whole this square. Then find the area of all 4 circles and just subtract them from each other. So what you have to do? Let me show you once over here. I already did that. Let me erase this thing. So as you can see over here, first of all, we need to find the radius of each of this circle, that is 3.5. Then what you have to do, find the area of square, that is 14 into 14, right? 196. Then area of the each circle, that is 4 pi square, then multiply with 4, that is area of all 4 circles. All we have to do, just subtract the area of all 4 circles from the area of the given square. And finally you will get the area of the shaded region. Simple. I hope the idea is clear. Still it is not clear, then write in the comment section. I will surely help you. That's one more part mostly come in the exam, that is this kind of sums. I already gave the solves of this. Just go through this one, and still if you face any doubt you can ask me anytime. So thank you for the circle. In the next part we will see the 3D objects. So today we're going to start the volume and area for solid structure like cuboid and cube. So the best way to draw the cuboid, just draw these two boxes like this, then join them together like this. 1, 2, 3, and finally 4. So we got the cuboid. Right now, as you can see, few sides are equal to each other. As you can see, this one L, this one should be also L, this one is as B, then this all should be also B. Okay, and this is as say H, then this one is also H. So there are some most important term for this kind of cuboid. That is, first of all, surface area. Surface area means, as you can see, there are 6 surfaces. So the addition of all 6 surfaces is known as the surface area, total surface area. So we need to find the area of each, right? So first of all, L, if we talk about this one, this area, then L will multiply with H. It is nothing but a perfect rectangular part. So we know that L into H, that means in this case the length into breadth, that is the area. Similarly, this area should be also equal to that. So we are joining them previously, so it is 2L into H. Similarly, for the top one, it will be H into B. Another bottom one is there, so same area, then 2 H into B. Finally, the front and the back. So that is, in this case, this is L and this is B. So 2 L into B. Finally, if you take the 2 as common, you will get LB plus HB plus BLH. So that is the formula for surface area. Okay, now what is lateral surface area? Lateral surface area means you need to find the height and the base first. Which one is your height this time? This is L, right? And these are the base part. Let me change a little bit. Wait a minute. I'm marking this one as H. That should be the height. So I'm just giving as H. Let me erase all this. So as you can see, this is H right now, this is B, and this is say L. This is how I am taking the current measurement. Okay. So for this kind of measurement, all you need to find first, that is the area of this and area of this. Let me use another color. Okay. So now we need to find the area of this side. Also we will add this with another side, that is this. So it will be H into B. So 2H into B for both of them. So 2H into B. Also we are going to do the same thing but for the base. Right now we are going to multiply this. Also we are doing for the front and the back. So what should be the formula? That is L into B. There are two parts, so 2L into B. So as you can see, if you take out, L into H. So as you can see, if you take out 2H as common, L plus B will be remain inside. So that is the area known as lateral surface area. Only these four surfaces, that is called lateral surface area. And if you talk about the whole surface area, that is all six surfaces. Similarly, we deal with cube as well, where there is no separation between L, B and H. All we need to know, we have to find the same kind of, in same kind of way, the surface area, lateral surface area. But instead of L and B or H, we can direct put over there A. So the formula will become, for surface area it is 6a square, for lateral surface area it is 4a square. You can also think it like that each of the surface area are perfect square. So each of the surface area having the area as a square. We know that while we talk about the total surface area, actually there are six surfaces. So that is why 6a square. Now if you talk about lateral surface area, that is all about four surfaces. So there are 4a square. Simple. Right now coming to the volume. Volume means what? The master formula for the volume is length into breadth into height, or a cuboid. So for a cube, what should be that? The length is also a, breadth is also a, and height is also a. So instead of this, we can write a cube. That is the volume of the cube. So that's it for the measurement of the 3D structure. And according to that, I provided all the formulas and all the solves of the important ones. Check it out. Still, if you have any doubt, you can write it in the comment section. Thank you.